Okay, so today we're going to finish with the volume, and then we're going to go over the volume of pyramids and the volumes of cones. So the volume of a pyramid is directly related to the volume of a prism. Do you guys remember what the volume of the rectangular prism was? What was it? Volume of a rectangular prism. Times width times height, right? Now the volume of the pyramid is actually length times width times height divided by 3. So it's 1/3 of the volume of a prism. Okay? So if you have a prism with the same length and width, okay, of this pyramid, it's going to be 1/3 of that. So to calculate the volume of the pyramid, you need to have the length and the width and the height. When we're talking about the height of the pyramid, we're actually talking about the height that goes from the top of the pyramid perpendicularly down to the center of the bottom, right? Of the base. So I need to know the height, which is a perpendicular line that goes down from the top to the bottom square, and I need to know the length and the width of that base. Okay? Now what if I don't know that height, but they have given me the slant height? So if they ever give you the slant height, which is the height of one of the triangles, you can't use it. You need to find the height of the actual pyramid to be able to use it. Okay? So you have to be careful what is given to you. This height right here, this one, the slant height, and this is not the one I'll be using in my formula for volume. Okay? I'll be using this height that goes down this way. Okay? So calculate the volume of this pyramid. It's as easy as just plugging everything in the calculator because I know the length, I know the width, and I know my height. So it's going to be volume equals 1/3 length times width times height. So that's 1/3, 18 times 15 times 25. They're all in centimeters, so that makes it easy for me. And then if I do that on the calculator, what do I get? Now it is, but before it wasn't. Okay, I just want to ask you a question. What if I gave you the volume of the pyramid, and I gave you the length and the width, and I asked you for the height? Can you find that for me? So what would you do? So I have volume equal 1/3 length times width times height. Let's say I have given you the volume, and I've given you the length, and I've given you the width, and I want you to find the height. What do you do? What would the formula be?
I pass the height to where the volume is, and the volume is going to be dividing those.
No. Multiplied by 3. The volume would multiply by 3.
So the first, so the first thing is you want to get rid of that 1/3, right? To get rid of that 1/3, you bring it here. It becomes multiplication by 3 because you're technically dividing by 3. So that's going to be 3v equals length times width times height. Okay, what do you do after that?
So height would be divided by.
Then divide by length times width because you're going to bring this over. It becomes 3v over length times width equals to the height. Okay, so this is just in case I gave you the volume, I gave you the length, I gave you the width, I want you to find the height for me. So we did this last semester. Isolating. No, we'll do that again this semester. We'll do that this year. Are we okay with this? Okay. Yeah. So we talked about the pyramids. I mean, the questions here, they're not going to get any more complicated than this. Right? Unless we start with optimization. Okay, when we get to optimization, it gets a little bit harder. Are we good to go to the next one?
So teacher, it will happen the same if we have to find the width of the length.
If you want to find the W, for example. Yeah.
So you just move it
So
outside to the other side and
right? So it's always the same step first, multiply by 3, and then you're going to divide by LH to find W.
okay.
Right? Yeah. All right. Now, the volume of the cone is related to the volume of the cylinder. Okay? So the volume of a cone is 1/3 the volume of a cylinder. It's the same thing as comparing the pyramid to the cube, right? Or not to the cube, to the rectangular prism. Okay? So the formula for the volume of a cylinder is, the volume of a cone is 1/3 pi r squared h. Okay? So a paper cup in the shape of a cone has a radius of 3.2 centimeter and a height of 6 centimeter. How much water can the cup hold? So when the question is asking you how much water can the cup hold, that means I'm looking for the volume. So we have the cup, we know the radius, we know the height. Again, the height is the one that's going from the cone. I can't draw a cone, unfortunately. Looks like this. So it's the height of the cone, right? It's from the top of the cone to the bottom, to the middle of the center of the circle. Okay? So in this case, volume is equal to 1/3 pi r squared h. I'm going to plug in the value of r. If they gave me diameter, what do I do? Divide the diameter by 2. What do you get? 64.3. If you're going to find the volume of the following figure, what do you do?
Separately find the volume, add them together.
That's right. Separately find the volume and add them together. Okay? So to separately find the volume, so volume of 1 is pi r squared 1/3 pi r squared h. So that's going to be 1/3 pi times 6 squared times 18. To 26.2. Is that what you guys got? No, wait. Yeah. That's right. This is not right. Okay, and that's volume 2. So same thing, 1/3 pi r squared h. The radius is still the same for both of them. The height is 24. Yep.
Question one.
Mm-hmm.
Yeah, answer.
You're getting a different answer? Can I see how you enter it on the calculator? Can I see? It could be because you're not putting multiplication. Because sometimes the calculator will not take the multiplication the same thing as the brackets. Because I put multiplication. Sometimes the calculator takes the multiplication and the brackets differently. Okay? Especially because you have that 1/3. Maybe try this for me. So if we do pi, and then bracket 3.2 squared, and then bracket 6, and then divide by 3. Or multiply by 1/3, same thing. So and then or multiply by 1/3. That's going to be the same answer. It's the process that the calculator is taking this in.
Okay.
Okay? Are we okay with this? Okay, now I'm going to add a little bit to this. Okay? And what if I gave you, and then the final answer is going to be the total volume is equal to V1 plus V2, right? So that's 678.6 plus 904.8. So what do you get for that? Okay, I'll give you time to copy this. I just need you to pay attention to me for a second. So if I have given you, if I've given you V and I've given you H and I asked you to solve for R, what do you do?
We reorganize the formula.
rearrange the formula. And what do you do to rearrange?
So it would be 3v first.
So 3v first. Get rid of that division by 3 first. Okay? So it's going to be 3v equals pi r squared h.
And then divided by pi and h.
Divide by pi and h, right? Because you have multiplication here, then you want to bring it over as division. So that's going to be 3v over pi h equals r squared. And then square root. So that means r equals the square root of 3v over pi h.
Wow.
It's called opposite BEDMAS, reverse BEDMAS.
That math needs.
We have a whole unit on rearranging formulas, by the way. We have a whole unit on rearranging formulas.
I can't believe like grade 12 is so.
But not this semester, right?
Yes, this semester. Otherwise, you don't have any more math after this. Okay, let me just get back to this 1 second.